Everyone, just wanted to take a moment to talk a little bit about the triangle midsegment theorem, and we're going to be using the midsegments to find sides and angles. So what are our goals for today? Well, our goals are to actually explain what a midsegment is and what properties it has, and then we're going to talk about how we can use those properties to actually solve for missing sides and angles and things like that. So what exactly is a midsegment? Well, a midsegment is just a segment that is joining the midpoints of two sides of a triangle. All right. So as you can see here, we have this midpoint, and this midpoint because there's three midpoints. Depending on which, and we're only connecting two at a time, we can ultimately make 1, 2, 3 midsegments. All right. An important thing to note is that, see, for this midsegment, if you were using these two sides, this side over here is the one that you're not including when you're making your midsegment. So that's just important to keep in mind, right? So when we're using these two midpoints to make this midsegment, we're not including this larger side over here, okay? So determining which side's not included in the creation of the midsegment is going to be very important for us later on. All right. So let's still talk a little bit about the triangle midsegment theorem. Okay, so if we have a segment that joins the midpoints of the two sides of a triangle, right, a midsegment. So if we have a midsegment, well, what can we say? The midsegment is parallel to the third side. So by the third side, it just means the side with the unused, so to speak, midpoint, right? So that's what we mean by the third side. So we're going to look at the side with the unused midpoint, and it'll be parallel to that side. And it is half of its length. So this right here, this is half of this longer one at the bottom, right? It's the one that we don't have the midpoint of for our midsegment. Okay. Now you will notice, because these are parallel, right? Because it's parallel, these are going to be corresponding angles. So now we know that this angle is congruent to this angle, and this angle is congruent to this angle. All right. So that's all the information that we get from the triangle midsegment theorem. The actual proof involving this it's a lot easier once we talk a lot more about dilations and things like that. So we'll kind of save going over the rationale for it for now. But ultimately, we just need to know that this segment, the midsegment, is half of the unused side, and that the midsegment is parallel to the unused side. Okay. So let's look a little bit over here. Part one, let's solve for the lengths, right? If we know this was 8, therefore this is 16, right? Because this is half of the one that's not used. So this one, y and 36, well, we know that y is half of 36. So y equals 1/2 36. So that would mean y is equal to 18. Now, normally they should have told you something like this, where you know these are midsegments, but for the purposes of the fact that we are talking about midsegments, we know it's a midsegment. Okay. All right. Let's do a slightly tougher one. This one will involve some algebra. So in the diagram below of triangle EFG, H is a midpoint and J is a midpoint, right? So basically, what are we saying? We're saying this is a midpoint and this is a midpoint. So whenever you see that, we know that this right here is going to be a midsegment. Okay. Okay. HJ is 35 minus 2x, and EG is 9x minus 47. So our goal here is to find the measurement of this. But we have to solve for x first in order to do that. So how are we actually going to solve for x? Well, what do we know about the midsegment? It's half of this. So that would mean that 35 minus 2x is equal to 1/2 9x minus 47. Now, I don't really want to deal with this fraction out front, so I'm just going to multiply this side by 2, right? If I multiply both sides by 2, that'll clear the fraction, and it'll make this, you just have to multiply everything over here by 2 as well. So 70 minus 4x, right? I'm just multiplying everything by 2, is equal to 9x minus 47. And the only reason I decided to do that was just because that makes things a little bit easier, right? So I add the 4x over to this side. I'll get 70 equals 13x minus 47. Add the 47 to that side. I would get 117 equals 13x. Now, what do we need to do? Well, we need to solve for x itself. So if you do that, plug it into a calculator or do it in your head, whatever works. I just double check myself to make sure I did it right on a calculator. And x will equal 9 when you divide by the 13. Okay, so now what do I need to do? I need to solve for actually this. Well, I can do one of two things. I can either plug it in here and just get it right away, or I can plug it in here and then multiply it by 2. It's really just a matter of whichever method we prefer. So if I plug it in here, I would get 9 times 9 minus 47, and that's what EG is equal to. All right, so EG is equal to that. So 81 minus 47. All right, so 81 minus 47 is going to be equal to 34. All right, now that is something, again, you can use your calculator if you want to confirm that you're right. I just double checked myself to make sure I didn't say the wrong thing and have to do the video over. But ultimately, this side is now 34. So that is what we are doing in terms of the midpoint, the mid-segment involving sides. And now let's look at it involving angles. So what do we know? We know that these two angles are going to be congruent, right? That comes from the corresponding angles because we have parallel lines, right? We know that these two are parallel. So you usually will see something like that. Or if you're told it's a mid-segment, you don't even need that. You can just use the fact that it is parallel. All right. So we know these are parallel, so these are congruent, and this is congruent. All right. So let's do a little bit of practice. So in the diagram below, we have that EF is the midpoint. H is the midpoint, J is the midpoint. So again, this is going to be a mid-segment. Okay. We know that this angle, JHF, right here, is 5x plus 54. And we know that GEH, this angle right here, is 93 minus 8x. All right, so what do we actually need to do? Well, we know that these two angles are congruent because this is a mid-segment. So these are parallel. Corresponding angles are congruent. So we can just set them equal to each other. Oh, they really like 13. So 13x is going to be plus 54 equal to 93. So 13x, when you subtract the 54, that would be 39. So x is going to be equal to 3. And now we're trying to find the measure of which angle GEH. So that would be this one. It doesn't matter, right? If I found it in this one, I could plug it in here. It doesn't matter. But I feel like doing this one because it will directly give it to you. Actually, they both will directly give it to you, and this one has subtraction. I don't want to deal with subtraction, so I want to deal with addition. So I'm going to plug it in here. So I know the measure of angle GEH is equal to this, which is equal to this. So I'm just going to plug it in there. I'll get 5 times 3 plus 54 equals 15 plus 54 equals 69. So it is 69 degrees. Okay. And that's all there is to it. And that's everything you would need to know about mid-segments. All right, so please let me know if you have any questions, and have a great day.